Hello, dear students. I am Samir Velankar. I welcome all of you to this another video on linked list data structure. From this video onwards, we will be learning how to write C program, for creating and managing a doubly linked list. Now, doubly linked list, as you all know, is nothing but a doubly linked list is collection of nodes again, like a singly linked list is collection of nodes. Whereas in a doubly linked list, suppose we assume a node which stores some integer data like 10. Now this node has two more members. Along with integer data 10, it has two more members which are previous pointer and next pointer. So every node will contain three members, data which is integer, and prev pointer, prev pointer, previous, and next pointer. Now next pointer will always store address of the next node. Say next node is storing 20 and next node will also have previous pointer and next pointer. Now observe previous pointer of 20 will store the address of 10, that is previous node, and the next pointer of 20 will store address of next node. So this is how the list grows. Now 30 will also have previous and next pointer. Previous pointer of 30 will store address of 20 and next pointer will store maybe address of the next node, which stores 40. 40 has previous pointer pointing to 30 and next of 40 maybe it is null because this is the last node. Now observe the previous pointer of 10 here, the previous pointer of this 10, which is the very first node, will be null. Why? Because previous pointer should point to previous node, isn't it? But 10 is such a node which does not have any previous node. So previous pointer of 10 is null and next pointer of 40 is null because next cannot point to any next node is not available, and intermediate nodes point to and fro. 20 points to 10 using prev pointer and 20 points to 30 using next pointer, like that 30 points to 20 using prev pointer and 30 points to 40 using next pointer. So such a list is known as doubly linked list. And now there are two more pointers, namely first and last. The first pointer will always point to first node. So whatever is the address of the first node will be stored by first. And last will always point to last node here. Last will point to this node 40. Now you recall just in the earlier videos, we constructed singly linked list in which we had only first pointer. We did not use last pointer, isn't it? Why we did not use last pointer there is because there was no point in keeping a pointer to the last node, because by keeping the pointer to the last node in a singly linked list, you won't be able to come back, because singly linked list has only one way link, that is forward link. But doubly linked list, in a doubly linked list, there is some sense in keeping a pointer at the last node always. So what we can do is, using this last pointer, we can quickly jump to last node. Once we jump to last node can take us to previous node, and then previous node can take us to previous node. Hence, we can traverse this linked list backward also, and we can traverse this linked list in forward direction from 10 to 40 also. Using the next pointer, we can traverse in forward direction, and using prev pointer, we can traverse in backward direction. I hope you are understanding. So this type of doubly linked list we want to create in these coming videos, where every node, check this now, check the node declaration. Every node, struct node, will store integer data, and every node will have two pointers. See how next and prev are inside the node, and next and prev itself are node pointers. So if you imagine node structure, just check this diagram. There are three members. First one is data, other one is a prev pointer, and next one more member is the next pointer. Now next pointer can point to any node, and prev pointer can also point to any node, such a node which again stores data and has two pointers, prevent next. I hope you are understanding. So there is only one difference if you compare this with the singly linked list program. In singly linked list program, every node stores integer data and next pointer. That's all, only one pointer, isn't it? Whereas in a doubly linked list, every node will store integer data and two pointers. Okay, I'll erase the slate now. So we have declared a node pointer. Node pointer, everybody understood, I hope so. Then we have written one function called insert node. Now this insert node function is going to insert only one node at a time in the doubly linked list. So imagine you want to insert 10 nodes, then you will have to call this function 10 times from the main program. We will not use any tricks of using for loop, asking the operator how many nodes you want to insert, n nodes, and then write a for loop. Silly, silly. We won't be doing that. Insert node will insert only one node at a time. So if you want to insert n nodes, call insert node 10 times or n times from the main. So that's insert node we have written. After that, we have written one function called display forward. This will display the list just as display function in singly linked list 2 videos back. But display forward and display backward, you watch, two functions have been written because we know that the linked list now can be printed in forward or in backward direction. Also, we have written one function called delete node. The delete node function will delete only one node at a time. We pass the value of x that we want to delete. For example, if we want to delete 20, then we will pass x as 20. After delete node function, we have main. Obviously, the entire story will start from main, isn't it? So let's discuss main. In main, check the declaration struck node pointer first, struck node pointer last. That means first and last are pointers which can point to any node. So what we have is, we have in the memory a pointer called first and a pointer called last. Now these two pointers can point to any node. But hello, we have not created any node till now. We have not allocated any node till now. We don't have any structure which stores integer data and two pointers. We will have to allocate memory for that. But currently we are only having two pointers, first and last, which can point to any node. Now the next line. First equal to null and last equal to null. You know first and last are pointers, so we have literally made them null. Now, in the previous program of linked list, we saw all this. In the previous program of linked list also, in the beginning of main, we had made first equal to null. Let's try to understand why we are doing this. Why we should initialize first and last to null. Now, if first is null, suppose, if first is null, then it means the list is empty. The linked list is empty. Ask yourselves, if there was at least one node, even if there was a one node which stores 10 here, then first won't be null, isn't it? Then first won't be null and first will point to this node 10. But there is absolutely no node now. In fact, the list is empty. Then what should be the value of first? First should be null. Indeed, that means whenever first is null, we know list is empty. Also, if first node itself is not there, then how come there can be a last node? So even last should be null. I hope you are understanding meaning and why we have initialized this first and last pointers. I guess you are following it. So after making first and last null, let's see the next line. Next line must be the call to insert node. See this line, insert node and first and last 10. So our aim is we want to insert a value 10 in the list and we are passing address of first pointer, address of last pointer. You know that first and last also will have some address, isn't it? So these two addresses have been passed. Now you have come a long way. You have seen description of singly linked list. So ask yourselves, what should be the parameter in the insert node function? In the insert node function, we should have pointer to pointer and again pointer to pointer because we are passing address of two pointers. So there should be two pointer to pointer and there should be one integer parameter. Okay, let's come to insert node function. Here is insert node function. Check. What is P receiving? P is pointer to pointer because it receives address of first pointer. So P is going to store address of a pointer. Remember, first is a pointer, and Q is receiving address of last pointer. So Q is also pointer to pointer. Two asterisks have been written. So what we had till now, in the memory we had first pointer, which was null. Look, main declared it. In the main we declared first. And last is also a pointer which was null. Now, this pointer first itself will have some address, and that address is copied in the pointer P. So P is 500. P literally points to first. Similarly, last will also have some address. Let's say address of last is 600. That address is copied in the pointer called Q, and Q is 600. Note that Q points to last. This is same as what we have learned in singly linked list, but my habit goes I repeat everything. So, what is asterisk P? What is asterisk Q from now onwards? Asterisk P means value to which P points, and that is nothing but first. And asterisk Q means value to which Q points, and that is nothing but last. So, in this function, if you write asterisk P or asterisk Q, you are accessing nothing but first and last. Okay. Now what next? After this, after first and last addresses have been copied in pointer P and Q, remember X is 10 here. The parameter X is 10. We want to insert 10. Let's start reading the function. There is one more pointer temp declare of node type. So we have one more pointer along with first and last. Temp is the pointer, and temp can point to any node. But remember, we don't have any node still. Now let's create a new node by using malloc. Create a new node. How do you create a node? Allocate memory for one node, and temp, the left hand side pointer, is going to point to that node. So new node is created, maybe at address 1000. Remember, this node has three members: data, prev, next. And temp is going to store the address 1000. So temp will point to that particular node. Also remember, this node doesn't have a name, but you can access data using temp arrow data, or next using temp arrow next, or prev using temp arrow prev. Okay. It is our good practice to check if temp is null. Temp will be null if malloc is a failure. If malloc fails to allocate memory, then temp will be null, and we will print cannot allocate memory and will stop the program. We saw all this in singly linked list program. We assume that this will never become true. We have enough memory. Okay. And memory will be never full, and allocation will be always successful. So throughout this discussion, we will assume that if is always false. Let's come to the next line. Temp arrow data equal to X, isn't it? And temp arrow next equal to null. These two lines. So temp arrow data, check this, temp arrow data. This data should be 10 because X is 10. And temp arrow next, let's say this is the next pointer, should be null. Actually, you all know that 10's next should point to next node, but next node is not there at the moment. So we have made next equal to null as of now. Okay, there is one more member called prev here, isn't it? Remember, there is a prev member. What should this prev be? Okay, right. If you are saying this prev should be null, you are correct. But listen, this prev should not be null every time. Now, after this line, check this, after this line, if I say temp arrow prev equal to null, straight away if I say this, without any if, without any condition, if I write new node temp arrow prev should be null, then I agree that this prev, the prev in the new node will become null, agreed. But what will happen when we call insert node for the second time? For the second time, blindly temp arrow prev will again become null. So we will have 10's prev null. Then when we will create a new node, its prev also will be null. We don't want this. We want only this time prev should be null. Are you understanding? But when I call the same insert node function second time, prev should not be null. What do you mean by this time? My statement is quite ridiculous as far as listeners will think. I mean, only this time prev should become null. Only this time means only first time, isn't it? Because this is the first node we have called for. But how will our program know that this is the first node? Come on, how will our program know that this is the first node? How will my program come to know that insert node has been called for the first time? Here is the if statement. Now I am marking. If first is equal to null, remember asterisk p is same as first. If first is equal to null, and it is, you note first is null. Tell me, if first is null, what does it mean? First is null means there was absolutely no node in the list before this. And whatever node you are just now inserting, whatever node you are creating, is genuinely, definitely the first node. Tell me, if first was not null, imagine for some time first is not null, then surely first will be pointing to some node. But look here. First is null at the moment. First is null means list was empty, and 10 that we have inserted, the new node that we have inserted is surely the first node. I hope you are getting. And if it is the first node, then check the next line. Check this next line. Temp arrow prev should become null. Only then prev should become null, because this is the first node. So temp arrow prev, this prev, the prev of the new node will become null. I hope you are understanding. And next we had already made null, isn't it? Next was already made null. After that, first will point wherever temp is pointing, and last will also point wherever temp is pointing. Remember, asterisk p asterisk q means first and last. So first equal to temp, last equal to temp. Watch, first will be no more null now, but first will point wherever temp is pointing, but temp is pointing to 1000. And last will also point, last will be no more null, last will be pointing to wherever temp is pointing. Okay, are you watching that first and last both are pointing to the same node, the node which stores 10 and the node which is located at 1000? That means first will become temp, that is 1000, last will also become temp, that is 1000. And after this if, after the if runs, after the if executes, else will not run, isn't it? Because if was true, so that will end the insert function. So congratulations, we have finished the insert function. First call to insert. Maybe it was a bit heavy, but I promise just a singly linked list, you will get used to this. Also, the insert function is getting finished. So these temp pointer, this q pointer, that is pointer to pointer, which were created as a parameter of the function, will get deleted. And also we will have a list now. You see, we are having a perfect doubly linked list. Do you agree that? Are you watching a doubly linked list? Yes, the doubly linked list is containing only one node, 10, whose previous is null and next is null. And first and last both point to the same node, obviously, because there is only one node. So the node 10 itself is first and node 10 itself is last. So both pointers are pointing to the same. I hope you got this. Very nice. Now let's say we call this insert node again, second time. This insert node is called for the second time, and this time we want to insert 20. So what was the latest doubly linked list we had? We had 10, prev was null, the prev pointer was null, and next pointer was null. Obviously 10 does not have any predecessor and successor. And first was storing address of this node 1000 maybe, and last was also storing 1000, because the only node we have in the list is 10. So both first and last point to the same node. Now imagine we call the same function for inserting 20. So what happens? You know, p stores address of first. I'm not going through all this again. Address of first was passed to p, and p becomes 500, so p points to first. Also, address of last pointer was passed, so q becomes 600, and q points to last. From now onwards, asterisk p means first and asterisk q means last. All right, come inside the function. The first line is declare a pointer temp, which can point to any node. So here is a new pointer temp. This pointer can point to any node. Next line is call to malloc. Allocate one new node, and temp will point to that new node, isn't it? So one new node is created which can store data, prev, and next. Maybe the address is 2000 where it was allocated, so temp will be 2000. So temp will point to this new node. What next? Now, we will ask if temp is null, but we assume this never happens. There is enough memory. Temp will be null if malloc was a failure. Anyway, forget it. Next line. Temp arrow data should be 20 because x is 20. And temp arrow next should be null because right now this new node does not have any successor. So temp arrow data will be 20 and temp arrow next will be null. Now comes the fun part. What should be prev here? What should be temp arrow prev? Notice temp arrow prev should be 1000. Are you understanding? Give yourselves a time. Temp arrow prev, the prev that I am talking about is this 20 is prev. What should it be? It should be literally 1000 because prev of 20 is going to literally store address of 10. Address of 10 is 1000, isn't it? And what should be next pointer of 10? Next pointer of 10 is currently null, but it should point to 20 now. That's how the doubly linked list is. 10's next will point to 20 and 20's prev will point to 10. So what should be next pointer of 10? It should be literally 2000 because it is going to store the address of the second node. I hope you get this. So these two things are to be decided. Okay. Now let's go to this if. Is first equal to null? Is first equal to null is the question. But first is not null. Very well, first is pointing to a node. So what do you know? First is not null. That means this is not the first node. This is not the beginning. That means we have already inserted some node earlier, and the node that we are creating is some next node or it is a consecutive node. This is not the first node, isn't it? So we'll go to else. We are in else now. And look how simple is this? How easy is this? Just check this. Temp arrow prev should become equal to last. You just check this. Pointer q is last, isn't it? Pointer q is same as last. So temp arrow prev should point wherever last points. Now just check the diagram. Take your time. Where is last pointing? Last is pointing to 10, to this node. And we are saying, check the statement again. We are saying temp arrow prev should point wherever last is pointing. So temp arrow prev, this prev will point to the same node where last points. Last is pointing to 10. I hope you are understanding. Last is pointing to 10. That is 1000. Address is 1000. Then temp arrow prev will also point to 10. That is address 1000, isn't it? Now one more line. Pointer q written in the bracket. What is this, by the way? Pointer q means, yes, last. Pointer q means last. So this is last arrow next. Are you getting it? Pointer q written in the bracket means last, isn't it? Last arrow next should be equal to temp. So last arrow next should point wherever temp is pointing. You know that temp is pointing to 20. So last arrow next, trace the cursor. Last arrow next. This next we are talking about should point wherever temp is pointing. Temp is pointing to 2000. So last arrow next, that is 10's next, should point to 2000. Are you following? Then this next will be no more null, isn't it? It is now pointing wherever temp points. One more line to go in the else. One more line. Asterisk q is equal to temp. This is last equal to temp, isn't it? So last should point wherever temp points. So last will discontinue to point wherever it is pointing, but it will point wherever temp points. So what are we going to now get is last, which was pointing to 10, will now point to 20. Last will now point to wherever temp is pointing, and temp is pointing to 20. Check this. Check this last line, isn't it? Last equal to temp. So last points to the same node where temp points. Obviously, now the value of last pointer won't be 1000, it will be 2000 because last has literally become equal to temp. And after that, the function ends after else. Congrats, you have finished the execution of insert second time, isn't it? Sorry for the poor count. I thought it is third time. Maybe I am getting too anxious about this. But the temp will be deleted, temporary pointers will be deleted. Agreed? then P and Q also will be deleted. And we are going to get back to main with first and last pointers pointing to first and last nodes. Now notice what an interesting doubly linked list we have got. Look at this. First is still pointing to 10. 10's next is pointing to 20, you observe. 20's next is null. Okay. And last is pointing to 20. Observe this cursor. 20's previous pointing to 10 and 10's previous null. We got a doubly linked list, isn't it? Okay, I'll clean the slate. Let's try it again. Suppose I have inserted 10 and prev is null. As you know, this is the first node, prev will be null. Next points to a node 20. Prev here points to previous node. Next is null. So we have got only two nodes in the list. First points to the very first node, maybe 1000 is the address. 1000 is the address. And last points to the last node, maybe 2000 is the address. So last is pointing to 2000. We will restart the insert node function with P. You all know storing address of first. You know what we are passing, isn't it? Address of first. So P will point to first and Q storing address of last. So Q will point to last. Now onwards asterisk P is first, asterisk Q is last. And assume that the parameter X is 30. We want to insert 30. So what's the summary? Declare a temp pointer which can point to any node. Here comes the temp pointer. It can point to any node. Next line, create a new node and let temp point to that new node. So new node is created, allocated, maybe at address 3000 and temp stores 3000. Now temp is pointing at this node which is storing 3000. We assume memory is allocated, so there is no question of failure. Then temp arrow data is 30, isn't it? Equal to X and temp arrow next is null. So data is 30 and next is null. Temp arrow next is null. We now want to discuss about prev. You tell me what should be temp arrow prev. Notice this temp arrow prev, what it should be, literally 2000. You observe temp arrow prev should store address of previous node. Address of previous node is 2000. Come on, that means temp arrow prev should store 2000. And what should be this next where I am hovering the mouse? That is next of 20. Next of 20 should be literally 3000, correct or not? Now identify, please identify this next where the mouse is hovering. How will you reach this next? Come on, this will be asterisk Q means last, arrow next. This next is last arrow next, isn't it? So last arrow next should become equal to temp. Are you understanding? Last arrow next should become equal to temp. Temp is pointing to 3000. And what about this prev where I am hovering the mouse? Temp arrow prev should become equal to last because last is pointing to this node. That's what I have written in the else section here. Else section says temp arrow prev should be last. So notice temp arrow prev, this prev should be equal to last. Last, you see, last is pointing to 20. So temp arrow prev also will point to 20. Same address. And how do you read the line which I am marking now? What is this line? This is last arrow next because asterisk Q is last. Last arrow next equal to temp. So last arrow next, observe this is last arrow next. This next should point wherever temp is pointing. I hope you are following it. And there is one more very interesting, very important line. Last equal to temp. Observe asterisk Q equal to temp. That means last will not no more point to 20. Last will no more point to 20, but last will now point wherever temp is pointing. So last will point to this new node. I hope you got this. Enough is enough. You must have got this now. Definitely last is going to be storing 3000, the address of this newly created node. You know, now gradually, you might be understanding, okay, what's the mentality, what we are doing exactly and why we are doing this. I'm sorry for this. Wait a minute. Why are such lines written? You might now easily understand. I am sure, GATE students. Let's see. Now, if we call this insert fourth time, don't worry, I'm not going to read it at all now. I'm not going to read throughout. But what we do in the insert function, give me the summary. Give me the summary. Whenever we go to insert function, we use a pointer called temp. Temp pointer points to new node. A new node is allocated. Maybe the allotment is at 4000. So temp will be 4000. Now we store temp arrow data with the value which was passed, that is x, 40. We have pre-pointer and we have next pointer in this node. But temp arrow next is invariably made null because it does not have any follower. But what about temp arrow prev? Temp arrow prev, this pointer, temp arrow prev is literally made equal to last. Observe, last is pointing to 30. So temp arrow prev also should point to 30, correct or not? And what about last arrow next? Check this last arrow next, this pointer, last arrow next. This should point wherever temp is pointing. Temp is pointing to 40. So last arrow next also should point to 40. But before we end this, before we leave the function, we say last, you cannot point any more to 30 now because now 40 has become the last node. So last, you better point to the same node where temp is pointing. Isn't it? Temp is pointing to 40. So last should also point where temp is pointing. That means last is now going to store address 4000. Look, we have got a linked list of 4 nodes storing 10, 20, 30, 40. I hope you have understood all the operations about the insert function. Now, the best way to learn this, you would find it funny, many students find it funny, is that I learned it by reading this again and again and drawing these diagrams line by line. As I go through every line, I used to read the lines, I used to draw the pictures. Only then I understood how the doubly linked list gets created. And the result of this was, as I executed insert node 3 times, 4 times, 5 times, ultimately all the statements written in the insert node function got memorized. Yeah, you won't believe they got memorized. I hate memorizing something, just as you would say that it's not good to memorize, it's good to understand something, isn't it? But the best way to understand a program like insert node is to run that program on paper by drawing the diagrams, not on the computer. You read each and every line, you draw the pictures. I bet on it that you will never forget the insert node operation. Thank you very much.